Welcome, welcome, welcome. We have systems of linear equations and inequalities review. Remember, this is part 2 of the 3-part review. Part 2 covers the substitution method and linear combinations for solving those systems of linear inequalities. This is a review, so remember, when I turn to a screen, you might want to pause the video, work out the problem, and then you can watch my solution and see if my answer matches yours, and if it does, then you got the correct answer and you can move on to the next one. We are trying to get you ready here for to be able to do this on your own, and that's what this is for. So I'm going to go ahead and get started here, and we'll go ahead and get this done. Let's read the directions. First, it says use the substitution method or linear combinations. So it's either one of those two that we're going to be using. In this case, we're going to be using linear combinations because if we notice that the numbers in front of y they're both 5 and they are opposite of each other. So that's the whole goal, is to try and get opposite numbers in front of one variable. In this case, it just happens to be y. So we're going to add both of those equations together. Negative 4x plus 1x is going to give us negative 3x. Negative 5y plus 5y is 0y, so those kind of just cancel out. And 7 plus 8 is 15. How are you going to solve and get x by itself? Divide each side by 3. And the negative, make sure you divide each side by negative 3. The negative 3's cancel out and leave you with x. And 15 divided by negative 3? Negative 5. Now remember, we're trying to find the point in which they intersect, so x equals negative 5, that is on the left side. And what's going to be on the right side? How do we find y? What you do with y is you pick one of those two equations that we had at the beginning. I'm going to choose the bottom one because it has x already by itself. So it says x plus 5y. Well, we know x is negative 5, so we're just going to substitute that in for x. X plus 5y is equal to 8. See how this lines up, with the exception of us substituting negative 5 in for x? And then we work this out, solving for y. We add 5 to each side, so 5y is equal to 13. And get y by itself. Y is equal to 13 over 5. And I'm okay with leaving it as an improper fraction because I know that you guys know that that is 2 3/5 as a mixed number. So right there will be your solution. That's where these two lines that we had at the very beginning, that's where those two lines will be intersecting. Okie dokie then. Man, that was a good one to start out with. This one here, a couple different things. We either have to try and get the numbers in front of the variables to be alike, or I'm looking at this x right here. That x right there allows us to, we could substitute fairly quickly. Let's subtract 3y from both sides of the top equation. So x and the 3y's canceled is equal to, let's say, 9 minus 3y. And now in this second equation here, 4 times x. Well, what's x? It is 9 minus 3y. And then we bring down the rest. Negative 2y is equal to negative 6. So the whole reason for doing that is now we only have one variable. We have that variable of y. First step to solving for y, distribute. 4 times 9 will give you 36. And 4 times negative 3y gives you negative 12y. Minus 2y is equal to negative 6. Combine like terms. So 36 and negative 12y, don't forget it's a negative 12y, minus 2. So negative 12 minus 2 is negative 14. and you're trying to get y by itself, so we subtract 36 from both sides. Those cancel. We're left with negative 14y is equal to, and negative 6 minus 36 is negative 42. Get y by itself, we divide both sides by negative 14. Y is equal to negative 42 divided by negative 14. Well, we know negative divided by negative is going to be a positive, and 42 divided by 14 is 3. So y is equal to 3. So in your answer, so y is equal to 3. That goes on the right side. So since y is equal to 3, we're going to go from here. We're going to find out what x is equal to. X is equal to 9 minus 3 times y, and y is equal to 3, so we plug a 3 in there. So x is equal to 9 minus 3 times 3 is going to be 9, and so x is equal to 0. And there you go. You have 0, 3 for your solution, and that's where those two lines that we started out with, so these two lines here, are going to intersect. That is the solution. 0, 3 is the solution. Okay. You have another one here. Looking at this one, remember you should be pausing these, trying to work these out on your own, or maybe if you want to wait until you see how I set them up and then go from there. Do this one a couple different ways. I'm looking at this. I see that y in the top equation all by itself, so that's the one I like. I want to go ahead and minus 2x from both sides. So we're left with y, because the 2x's cancel. We're left with y is equal to, what's 0 minus 2x? Well, 0 minus 2x is just going to be negative 2x. So we know what y is equal to. It's negative 2x. So right here, for y, we're going to put negative 2x. So we have 5x minus 4 times negative 2x is equal to 26. We've just substituted in for y. Let's go ahead and order of operations. We multiply before we add and subtract. So negative 4 times negative 2x. Negative 4 times negative 2 is going to be negative 8x. And you might wonder why we can multiply negative 4 and negative 2x, because they're not like terms. Well, you have to work with like terms when you add and subtract, not when you multiply. When you multiply, you just multiply. No. You have to pay attention to the terms, but you don't have to have like terms to multiply. And I kind of messed up here. It's not 5x minus 8x. Remember, we have negative times a negative, so we get a positive. And that's equal to 26. And let's go ahead and simplify and solve for x. 5x plus 8x is 13x, and divide both sides by 13. So x is equal to 2. X goes on the left side, so since x is equal to 2, we put 2 on the left side. And since x is equal to 2, we plug it right in there for x. Y is equal to negative 2 times 2. And negative 2 times 2 is going to be a negative 4. And then we write negative 4 on the right side. And so we have our solution. You can always check your solution and plug xy, plug x in both equations for x, and plug y into both equations for y. And then in the top, whatever you get on the left side should equal 0. And in the bottom, whatever you get on the bottom equation, whatever you get on the left side should equal 26. And if that's true for both of them, then you know you have the correct answer. That's one way to check your solution. All right, looking here, This one's I'm looking, I see the y is all by itself, right? Well, it has the 1 with it, which is good. We just minus 4x from both sides, and we could use substitution. But I see something I like a little bit easier. Right here, I see a 4x and a 4x for both of those equations. So I'm thinking linear combinations is going to be best here, because by using linear combinations, we can just multiply one of the equations by -1, and that just flips the signs. So if we multiply this equation by -1, what really happens? Well, we change the signs on everything. So what's -1 times 4x? You get -4x. And what's -1 times -3y? You get +3y. And -1 times -2, you get a +2. So instead of rewriting that equation, I'm just going to change those signs. And now I'm going to add 4x. I'm going to add 4x plus -4x is going to cancel to give us 0x. 1y plus 3y is 4y. And 4 plus 2 is 6. Divide by 4, so y is equal to, I know 6 over 4, each number reduces by 2, right? I can divide each one of them by 2, so 6 divided by 2 is 3, 4 divided by 2 is 2. So y is equal to 3/2, so we put that on the right side. And now we need to plug it back in and solve. Plug it back in and solve. I'm going to plug it into the top equation here. So 4x plus y. What's y? It's 3/2. 4x plus 3/2 is equal to 4. And you're trying to get x by itself, so you probably want to subtract 3/2. Subtract 3/2 from both sides of the equation. Well, that cancels. We're left with 4x is equal to. And now if we look here, we can't say 4 minus 3x. We cannot do that because they don't have a like denominator. So the denominator of 4 is a 1. So how do we change the 4 over 1 to have a denominator of 2? Because 3/2 has a denominator of 2. And we can take 1 on the bottom, multiply it by 2 to get 2. So if we multiply the bottom by 2, we got to multiply the top by 2. So now we have 8. So 4 is equal to 8 over 2. And that makes sense because the 2 goes into the 8 4 times. So here we can subtract. What's 8 over 2 minus 3 over 2? It's 5 over 2. Okay. Now we're solving this out. 4 times x is equal to 5 over 2. Now you can think about this. Since the right side is a fraction, I don't necessarily want to divide by 4 because really if I divide by 4, this is what it's going to look like. And then we're eventually going to say, well, how do you divide fractions? Well, a fraction divided by a fraction, you multiply by the reciprocal. So, I mean, you can put that on your paper. But really what you're doing is you're multiplying. What's the reciprocal of 4 over 1? It's 1 over 4. So go ahead and multiply those numbers out. Top numbers multiplied give you 5, and the bottom two numbers, 2 times 4, will give you 8. So really we have x is equal to 5 over 8. And we plug that in there for x. All right then. So moving right along. And if we look there, we are looking, there's a number in front of x's and y's, so substitution is probably not going to be the best method here. We're trying to always either look for x to be by itself, well, with the invisible 1, or the y to be with the invisible 1. So we're going to use linear combinations. Linear combinations. We either have to make these numbers in front of the x to be the same or the numbers in front of the y's to be the same. How can I do that? Well, the numbers in front of the x, I'm looking 3 and 2. The least common multiple of 3 and 2 is going to be 6. If we look at 5y and 6y, the least common multiple of 5 and 6 is going to be 30? Yeah, is going to be 30. So I'm going to go ahead and get rid of the x's first because, well, number one, because the 2 has a negative sign with it, but also I like working with the least common multiple of 6. It's smaller. So if we have to make that 3 a 6, what do we have to multiply it by? We have to multiply it by 2. If we have to make this 2 a negative 6, we have to multiply it by a positive 3. And remember, you have to multiply everything in the equation by 2 on the top. So 2 times 3x, 6x. And 2 times 5y is 10y. And 2 times negative 16 is negative 32. Now on the bottom, 3 times negative 2x is negative 6x. 3 times 6y is 18y. And 3 times negative 36, large number. Well, we know it's going to be a negative, right? So 3 times 36. Well, 6 times 3 is 18. Carry your 1. And then 3 times 3 is 9 plus 1. That makes 10. So all right, this is where we're at. Since this is a positive 6 and this is a negative 6, they're opposite of each other, and we are good to go. We are ready for liftoff. 6x plus negative 6x is going to be 0x. Those cancel. 10y plus 18y is 28y. And negative 32 plus negative 108 is going to be negative 140. To get y by itself, we divide both sides by 28. Divide both sides by 28, so y should equal negative divided by positive is a negative, and 28 goes into 140 5 times. So y is negative 5. So if we look, since y is negative 5, which one do you want to plug it into? Let's plug it into, it doesn't really matter. Either one you're going to get x. So we're going to plug it into negative 2x into the bottom one. Negative 2x plus 6 times negative 5 is equal to negative 36. You notice this is y, but where are we getting that from? We're getting it because y is equal to negative 5. Work this out, we're going to get negative 30. 6 times negative 5 is negative 30. Trying to get x by itself, so we have to get rid of positive 30. Or I'm sorry, we have to get rid of the negative 30. And what's the opposite of subtracting 30? We add 30. And make sure you add 30 to both sides of the equal sign. So negative 2x, the 30's cancel. Negative 2x is equal to negative 36 plus 30. Negative 36 plus 30 is going to be negative 6. And divide both sides by the negative 2. So x is equal to negative 6 divided by negative 2 is a 3. So x is equal to 3. And you have found the ordered pair in which those two lines intersect. This next one here, if we look, here's the substitution method or linear combinations to solve the linear system of equations. I'm looking, it has a negative x. That's a possibility. I mean, if we just add x to both sides, then subtract 24, that's going to give us x by itself. So we have negative x plus 3y is equal to 24. Add x, so those cancel. So 3y is equal to 24 plus x. And we're trying to get x by itself, so we can substitute 3 minus 24. So 3y minus 24 is equal to x. And now, since this is the equation that we switched around, we cannot use this one. We cannot plug what we've switched around back into it for x. But we have to do it with the other equation. Plug it in there for x. So we're going to do that. 5 times x. What is x equal to? 3y minus 24 plus 8y, and that's equal to negative 5. And so now let's distribute here. 15y. 5 times 3y is 15y, and 5 times negative 24 is going to be a negative, and 5 times 24 is 120. Drop everything else down. And we can combine like terms, right? 15y plus 8y will give us a 23y. And trying to get y by itself, add 120 to both sides. 23y is equal to negative 5 plus 120. Negative 5 plus 120. I don't know what I'm thinking here. It's positive 115. And we divide both sides by 23. That's going to be an easy one there. 5. 115 divided by 23 is 5. Okay, so in the upper right-hand corner, we're going to go ahead and write part of our answer. So 5, y is equal to 5, so we put that there. And since we know that y is equal to 5, we plug it right in there for 5, and we can solve it out for x. So we say 3 times 5 minus 24, that's going to be equal to x. 3 times 5 is 15. And what's 15 minus 24? It's a negative 9. So x equals negative 9. We plug that in right there. Yeah, so that's where we're at. Okay, let's look here. None of the variables have a 1 in front of it or a negative 1 for us to move some things around for substitution. But I am looking, I'm looking right here. I don't like these y's. I like the x's better, because what do I have to do to make those x's be the opposite of each other? All I have to do is multiply this by negative 2, right? Because negative 2 times 2x is going to be negative 4x. And if I wanted to do that with the y's, I would have to multiply 6 by 6 to get 36. Then I would have to multiply 9 by 4 to get 36. And that's the least common multiple there. But 1 has to be positive, and then 1 has to be negative. So I actually have to multiply one of them by a negative number. So we're going to get rid of the x's. So let's go ahead and multiply here. Negative 2 times 2x is a negative 4x. Negative 2 times 6y is negative 12y. And negative 2 times 1 is negative 2. And just bring this other equation over. 4x plus 9y is equal to 2. So this is where we're at. And we are moving right along here because the numbers in front of x's are opposite of each other. So those will cancel. And we go ahead and add 9y plus negative 12y, negative 3y, and 2 plus negative 2, 0. That's an easy one to figure out, right? Y is equal to 0. Yeah, y is equal to 0. You can't beat that. We'll just go ahead and use this bottom equation again. So 2x plus 6y. What did we just figure out y was? 0 is equal to 1. And we know negative 6 times 0 is 0. So we have 2x equals 1. Divide both sides by 2. X is equal to 1/2. And this is the point in which those two lines will intersect. And if you're doing this on the graph, you might have a little tough time, if you're graphing both of these, have a little tough time on making that exactly, trying to figure out that the point where they cross is exactly at 1/2, 0. You can come up with a guess or an estimate there and get real close, but if you're doing it on a graph, that's the reason why we use substitution and linear combination, so we can be exact. All right, so let's look here. This is a toughie here. A couple different ways you could do this. Couple different ways. The way that I'm going to suggest is we're going to use substitution here. And how are we going to use substitution? Right here. You see this is 2y, this is negative 4x, and this is 6. I'm dividing the left side by 2, so I can divide the right side by 2 also. So I'm left with y, and negative 4 divided by 2 is negative 2x, and 6 divided by 2 is 3. And see there, y is by itself, so now I just have to get rid of this 2x. And now I have the equation. Okay, so now we're looking at this equation here. We have canceled those out, so now we have y is equal to 3 plus 2x. And now that we know what y is equal to, we can, since we've manipulated the bottom equation to get what we have here, y equals 3 plus 2x, we have to plug it in, whatever y is equal to, we have to plug it into the top equation. So we're going to go ahead and do that. 2 minus 7x is equal to 9 times y, but what did we figure out y was? 3 plus 2x. And so now we just solve for x. 9 times 3 will give us 27, and 9 times 2x is going to give us 18x. So we go from here. Let's add 7x to both sides. So we're left with 2 is equal to 27 plus 25x. And then how do we get x by itself? We have to subtract 27 from both sides of the equal sign. So negative 25 is equal to 25x. And divide both sides by 25. So therefore, x should equal 25 divided by 25 is 1, and a negative divided by a positive is a negative. So x is negative 1. So that's what we put there for x, negative 1. And we're going to substitute, since x is negative 1, we're going to substitute it in there for negative 1 and find out what y is equal to. And work it out. Y is equal to 1. So if we look there, the solution is negative 1, 1. And that's what we have. It's where those two lines that we began with will intersect, will cross. All right, let's look at the next one here. Oh, these ones are lovely. You have the numbers in front of the x are opposite of each other. And hey, look here. The numbers in front of the y are even opposite of each other. That's awesome. Well, we know linear combinations are going to work with that. Look at that. Let's go ahead and add those. 2x plus negative 2x cancels to give us a 0x. And negative 3y plus 3y cancels to give us 0y, and 1 plus 1 is 2. If we look there, that's awesome. Because we just close to our answer. And you know if you have 0x plus 0y, 0x is 0, 0y is 0. So 0 plus 0 is equal to 2. Or I'm sorry, 0 plus 0 is 0, and then that's equal to 2. So 0 is equal to 2. All right. You're wondering how 0 is equal to 2? It's not really. Oh, what can we do here? 0 is not equal to 2. So you put that little line there saying it is not equal to 2. And when you come up with a statement here, when there's no variables, so you're just only looking at just numbers without variables, and when you come up to this statement where 0 is not equal to 2, or you come up to a false statement, because this is false, it's false, that's why you put the not equal to sign in there, the answer will be no real solutions. No real solutions there. And if you look and figure that out, those two lines are not ever going to cross. So if they don't ever cross, that means they are not, that means they're parallel. And if you just say no solutions, I think that'll be sufficient enough. We're not into talking about real and imaginary yet. So no solutions is what the answer would be like. And the last one here, we have these two equations. These two equations, what are we going to do? It's a tough one. We know substitution is not going to work as it stands right now. So what are we going to do? I know 9 times the number is not going to give me 21, and I know 12 times the number is not going to give me 28. But I do notice that I can divide 9 by 3 and I can divide 12 by 3. So if I divide everything on the left side by 3, I have to divide everything on the right side by 3. And that's going to give me 9 divided by 3 is 3. 12 divided by 3 is 4. And 6 divided by 3 is 2. Okay. But also look up here. I can divide everything up here by 7, right? 21 divided by 7 28 divided by 7, and 14 divided by 7. So 21 divided by 7 is 3x, and 28 divided by 7 is 4y, and 14 divided by 7 is 2. And so now we're looking here, and the numbers in front of the x are the same, and the numbers in front of the y are the same, so we just need them to be opposite. So multiply this, let's just multiply the bottom equation. Multiply the bottom equation by -1, so that gives us negative 3x. It will give us a negative 4y and a negative 2. So let me go ahead and get rid of that -1 there. So that's, we multiplied everything by -1 to get this bottom equation. So now let's go ahead and add those. 3x plus negative 3x is 0x, and 4y plus negative 4y is 0y, and 2 plus negative 2 is 0. 0x is 0, 0y is 0, so 0 plus 0 is 0. So 0 equals 0. Is that true? Yes, that is true. So if we come up with a statement here involving numbers without variables, and that's a true statement. The last one, the example, was a false statement, so it had no solutions. And if this becomes a true statement, this will have infinitely many solutions. Infinitely many solutions. So if we think about that, infinitely many solutions, what's that mean? It means if you have a line and then the other line lies right on top of it, they are the same exact line. And you notice that, you might have noticed that right here, is that on the top one was 3x plus 4y equals 2, and on the bottom one, before we multiplied by -1, was 3x plus 4y equals 2. So they were the same exact equation, which meant they were the same exact line. And when that happens, infinitely many solutions will be the answer there. Okie dokie then. That'll wrap up part 2 of your chapter review. If there's anything that wasn't clarified here on the video, make sure you let me know. We will see you on the next one.